Hello everybody, welcome to this tutorial for Ansys Discovery where we're going to do a fluid flow simulation. Let's get started. When you first launch Ansys Discovery, you'll see this welcome screen. If this is your first time using Discovery, please go through the content on the welcome screen to learn about things like UI components, navigation, selection, using tools, getting help, and so on. Click here if you don't want to show the welcome screen on startup for future sessions of Discovery. Otherwise, click here to open the home page. In the home page, click on Browse, open Geometry File, navigate to the appropriate folder, select the geometry you want to import, and click Open. Okay, this is the geometry we're going to use for this tutorial. Now, the first thing I want you to do is let's take a look at the inside of this geometry. So to do that, click on the Z-axis in the global coordinate system and hit the X key on your keyboard to go into cross-section mode. As you can see, this particular CAD model has the solid part of the geometry, but the internal volume representing the fluid domain doesn't exist. So the first step is actually to create this internal fluid volume. So let's go ahead and do that. But first, hit the D key on your keyboard to go back into 3D mode or to exit cross-section mode. Okay, so up on the top on the ribbon, you'll see we are in the Simulation tab by default, but there are many other tabs available for you. Let's click on the Prepare tab and launch the Volume Extract tool. The moment you do that, you'll see that the HUD or head-up display is shown, and this basically puts all the inputs and options for this particular tool right at your fingertips. So let's zoom in. Let's select this face and this face, and then finally this face. Okay. Now click on this icon, which will enable you to select a seed face and then just pick any internal face and hit the green check mark to extract the fluid domain. So you can see the fluid domain has been automatically created. Now to dismiss the HUD, hit escape 2 times. Okay. Now when you're done with the volume extract, you can click back on the simulation tab to give you access to all the simulation specific icons. Okay. The next step is to apply some boundary conditions, and let's do it as follows. So rotate the model. So these are the 2 inlets. Click here and click on the hex icon to launch the halo. The halo is an easy way for you to access all the common tools that you'll need. So in this case, let's choose the fluid flow icon and click here to apply a flow condition. Now, once again, you'll see the heads-up display or HUD is launched. Now, one thing I want to point out is if you're ever confused about what these icons do, you can click F1 to launch our overlay help system. To exit the overlay help system, just hit F1 again. So in this case, we're going to assign a velocity of 1 meter per second to this inlet. Okay, and then we're going to click here to apply a temperature. And the temperature we're going to apply, let's take the default of 22. So we're good to go there. Now let's click on this face. You'll notice that it keeps all the inputs from the previous condition. So let's retain the 1 meter per second velocity. But let's click here to say we want the temperature on this inlet to be 50 degrees Celsius. Okay, so we have defined these 2 flow inlets, and you can see them show up on the physics tree on the left. Okay. Now let's hit escape 2 times to dismiss the HUD as usual. Now I want to show you a slightly different way to apply similar inputs. So you can use the icons on the ribbon to launch these tools as well. So let's click on Fluid Flow and click the Flow tool. And then once the tool is launched, you can see the heads-up display shows up on top. You can control select these faces. Okay, this is just another way to do the same thing. The only other thing we have to do is change it from type inlet to outlet by clicking here. And we'll accept all these defaults. So just click the check mark. And we're done. And a reminder to hit escape 2 times to dismiss the heads-up display. Okay, you can always review the inputs you've applied by hovering over those items on the physics tree on the left, and you can see the corresponding faces get highlighted. Now there's one more thing we need to do. You'll see the default fluid that we're going to use is liquid water. We need this to be air. So let's double click on this item on the tree to launch the heads up display for material conditions. Now where it says water, just highlight and just start typing in the word air, and you'll see it shows you the material properties that are available by default in Discovery. So choose air, and you'll see that the material has been changed to air from liquid water. So we're done. We can hit escape again 2 times to dismiss the HUD. Now, down at the bottom, you'll notice the simulation information display has various icons which help you understand what's going on. So it shows you the fluid flow symbol or icon, but it's also been colored to show that in addition to fluid flow, we're also solving for temperature because of the different temperature conditions that we applied at the inlet and outlet. Okay, so this is pretty much it. Let's click the green solve button to get started. Okay, now in explore mode, which is the default, we're using the power of the GPU to run very, very fast, almost real-time simulations. You can see here we already have some results. Let's go back into cross-section mode by clicking on the Z-axis in the global coordinate system and hitting the X key on your keyboard. Now let's reorient this, and an easy way to do this is to click on the Z-axis in the view triad on the bottom left corner. There we go. And you can see that by default, we're showing you streamlines of fluid flow colored by velocity. Now, in the bottom right, in the results arc, we have many different result types. So let's investigate a few of those. So let's turn off the streamlines by clicking on this icon, and let's turn on contours by clicking right here. Now, this shows you velocity contours, and you can change the variable that you're displaying by clicking here. So let's change that to temperature. And here you can see the temperature distribution. So obviously in this case, we have hot air coming in from one inlet and colder air coming in from the other inlet. And you can see how they're kind of mixing, or in this case, really not mixing. And you can see the very non-uniform distribution at the outlet. So this is the case for both temperature. And if we click here to change back to velocity, we see the same thing. Most of the flow you can see is going through just one channel in the outlet, which indicates that this is perhaps not a optimal design. But that's really the whole point of simulation, to identify problems with your design. Now, in this tutorial, we're not going to make changes to the design. So I just want to show you some more results options. So let's turn off the contours, and let's turn on velocity vectors. And we can zoom in to see what those look like. These are 3D velocity vectors. Okay. We can turn those velocity vectors off and click here for particles. Let's click on the plus Z in the view triad again. And this once again very clearly shows you that most of the flow is going through that one channel. And in fact, we have reverse flow coming in through the other outlet. So there's actually flow going back into the duct system, which certainly means that this is not an ideal design. Okay. So, take the time to investigate these various options. The one last view result option I want to show you is the LIC plot. So let's turn off particles by clicking here, and let's turn on the LIC plot. Now you'll notice that this LIC plot is not oriented perfectly, but you can click on this little blue sphere and then double click on this curved red arrow to just snap that 90 degrees. And this shows you even more clearly the kind of poor flow distribution from this particular design. Okay, so there you have it. In part one of this tutorial, we have done a very quick GPU-powered exploration of this design. We have viewed, the flow, velocity, and flow temperature distributions. And in the next video, in part two, we're going to do a higher fidelity solution of the same problem using all the inputs that we have provided, but then adding on some advanced controls like mesh and convergence monitoring and so on. So this ends part one. Please go to part two and review how we can study the same problem in much higher fidelity. Thank you very much.